Kia ora koutou. Thank you to my colleagues for introducing the topic of inequities in New Zealand currently. I'm going to be talking about some of the things, but I'll try to touch inequities topic as well, so thank you for that. Let's talk about pipes. Yay, how exciting. How on earth do we get from pipes to let's work on it? For that, we have to understand the rationale of our work. There are, as researchers, there are certain things that we know and things that we don't know so much about. One thing that we know is that people can get sick from drinking water contamination, that this can be microbial or chemical, and that it can happen at the source during the treatment or in the distribution system, which is what our research focuses on. Another thing that we know or we estimate is that there's around 2,700 cases per 100,000 population of gastrointestinal illness yearly in high development countries, and it's attributed to drinking water, from which 37% are attributed to the distribution system alone. And one thing that we don't know so well is the actual burden of waterborne disease in New Zealand. There's some estimates from 2006 that are ranged around 18 to 34,000 cases of enteric disease yearly. Something that is known is that there are potential chemical threats in our drinking water that are found frequently, such as lead, aluminium, or asbestos. It's known as well that the water infrastructure is facing major deficits of $120 to $185 billion currently. Pipes are old, there are some in poor condition, and there is plenty of leakages, water loss, and outages happening in Aotearoa, New Zealand. Finally, one thing that we know now is that the data quality and availability is very limited in New Zealand on drinking water regulation due to lax regulation, no data standards, and inconsistent recording. So to our knowledge, there is no previous data set, and that's why we set one of our goals to create a national spatial data set on drinking water reticulation. And once we had it, to compare these results to previous estimates in other comparable countries, as well as investigating deficit disparities by regions and councils, assessing the inequities in exposure to poor pipes by ethnicity and deprivation, and finally evaluating potential equity implications of new local water and well policies. Just as a background, this research is funded by TENIFA, which is the infectious disease research platform, and it's led by Tim Chambers in the bottom right of these pictures, but Matt present and Dr. Marek also collaborate on it. For this investigation, our study population is the people that is connected to a registered water supply, which makes up for 85% of the total country population. And there are 629 such public supplies that we had previously mapped and created a data set for last year, which we published and used in some other research that looked into structural inequities in data quality, some other unpublished research looking into access and performance of community water fluoridation. So moving into the methods that we used in this research and trying to be brief about it, we had to collate a lot of data from 67 different councils. So it meant a lot of official information requests, painful waiting times, and we also got information from their online repositories when available. And once we had all that data, a complete data set, we had to standardize it. So we created some variables, such as the pipe age or the pipe material that we can see in those example maps of Invercargill up on the right. And other than the standardized variables, we had to derive some of them. One was the supply code, which we got from that other previous data set by linking the pipes to the supply that they were on. But also life expectancy, which was derived from literature. And we graded the pipe condition as well based on the age and the life expectancy. Then after having standardized data, we had to aggregate it by supplies, but also by councils and for the whole nation. And on the process from getting to a raw data set to an analytic data set, we had to do some exclusions on the right, which included removal of abandoned pipes, pipes that were not connected to a supply, and pipes missing material or age information, which left us with an analytic data set that we could finally analyze. And the analytics comprehend descriptive statistics at a national, regional, and supply level, but also spatial clustering analysis, multi-level regression analysis, and weighted disparity ratios for ethnicity and deprivation, which are some statistics showing how likely different ethnicities and different deprivation levels are to live in areas with poor pipes. Some of those results can be seen here in this table for the whole country. Out of the 57,000 kilometers of pipes, we found that the mean weighted age was around 38 years, which is quite old, and the proportions of pipes past the life expectancy or useful life was 18.5%, ranging from 8.7 to 28, depending on the case scenario. Then we also classified the condition of pipes and the percentage for each condition, and the types of materials presented in our network, with plastics making up for 2/3 of the reticulations. These are, as we can see in the histograms, newer pipes. These are the ones that are being installed right now, and we can see how almost none of them go past their life expectancy. With that, it's different when we go to metallic pipes, which are quite older and all past the life most of them past the life expectancy. The case of asbestos cement pipes, which are 20% of our reticulation, and these were quite popular in the 60s, 70s, and 80s, but then they got banned, and the thing is that they're still in the reticulation. So they're being renewed, but at a very slow pace. So what can we get from that? Is that there is a great percentage of the reticulations in suboptimal conditions. How do we know that other than because I say so? We know it because it's higher than previous estimates in other comparable high-income countries. As we can see here in this table on gray, we have our results for New Zealand. And if we look at the age rows, we see how pipes are older here than in other comparable countries other than perhaps the USA, which is kind of similar. Same for the condition variables on the bottom. And if we look to the right, we see previous reports done by Water New Zealand and Taumata Arawai, which is the current water regulator. And these reports were done by self-response from the councils. And they saw as well as smaller numbers than the ones we found, which means that most of the current estimates on water renewals and asset value are underestimating what the problem is. Some of the other results, we had to map them because that's what we do in the GeoHealth lab. And on the left, we can see the percentage of pipes past the life expectancy by council. And at a simple glance, it's clear that the North Island is performing worse than the South Island, with some exceptions in the bottom, like Invercargill or Dunedin. On the right, we have the odds ratio from the multi-level model. Those close to 1 are average, while green is good, purple is bad. And in the middle, we have the clusters of high, or poor pipes in purple, and the low, or good pipes in green. There are 4 different low clusters, 6 different high clusters that are repeated among the cases and areas. And finally, the weighted disparity ratios that we got. When we look at ethnicity and we take European as our reference ethnicity, we can see how, in the case of Maori, they are similar or slightly more likely to live in areas with worse pipes, but Asian and especially Pacific are much more likely, and in some cases, such as the Pacifics, are 19% more likely to live in an area with pipes past the life expectancy. Same was done for deprivation, and using low deprivation as our reference, we saw how people living in moderate deprivation or high deprivation were more likely as well to live in areas with suboptimal pipes. So from those 2 results, we can tell that there's substantial difference among regions, and it could play an important role in upcoming policy. And there are substantial difference between areas of deprived population and different ethnicities, which could be mapped as we've done here to show with in our Invercargill example again. In purple, we can see the pipes that should be aimed for in future renewals if councils want to tackle A, the deficit, but B, the inequities as well. Finally, future research will benefit from looking at additional pipe features once this data becomes, if it ever does, universally standardized. It could add other factors to the assessment of pipe condition, like operational and environmental factors. other than just physical factors that we included. Once the new policy gets approved, it will clarify some implications of the inequities related to amalgamations, which is how the new council control organizations will be formed, and how likely it is that some poor performing councils are going to be left out. And finally, we will use this data on reticulation quality to compare it against water quality data that we have compiled for different supplies to estimate the effects that the reticulation quality has on the water quality, and ultimately we'll try to link it to the waterborne diseases and estimate how much it affects on it. Thank you.